Hi, my name is Stephanie Honore, and today I'm going to give a demonstration of an exercise located here at stanford.edu. This exercise concerns vectorization. So what vectorization is when you're doing machine learning and you have the learning algorithm, um, it may take, for example, 20 minutes to run to complete, and you use vectorization to optimize your algorithm so that your code or your program can run in less time. So the concept is that you speed up the algorithm by removing for loops and iterations by putting, for example, z equals theta times x. So this reduces the number of lines of code that you have, and it also executes faster. So let's go to the exercise here. All right. So you go to the exercise and you actually have to complete a prerequisite program. So this sparse autoencoder, you have to do that one first. So basically this one is concerning neural networks and training your data and then visualizing that trained data. So after you complete that, you can come back to this tutorial and not view the rest of what I have to say. So basically, you're adding on to that code for the sparse autoencoder. And to do that, first you would download these two files. One is training images and one is training labels. And then the starter directory, let's do this way. All right, so this starter directory should contain some files from that when you run this sparse autoencoder program. Uh, you're going to add two more files. I called mine load MNITS images and load MNITS labels. And I click on these. You have to open them with MatLab. All right. Oh no, none of these are right. All right. Here is the code that we added. So it's a function, and you're loading those training images in this one that load MNTS images. The point of this one is to take the downloaded training image, which is located here. When you unzip it, it should be train images IDX3 U byte, and it's processing that. And you do the same thing for the labels. So you're opening this train labels IDX1 U byte, and you're processing it. All right. So once you create those files, you're going to update some of your files that you already have, and it tells you here what you need to update. So first thing you're going to do is in the sample images. So the patch size that they want us to use is 28. And the number of patches is 10,000, so that you already did that. And so I know I said earlier when you do vectorization you reduce for loops, but you do need this for loop. So for I in the number of patches, x is equal to your max, your x max, and y is equal to your y max, and your sample equals images and this range. And then you normalize the data, which you already should be doing. And that's the function to normalize the data. And then next, train. All right, in the training, you're going to add change the file names that you save under. So you're going to add variables for your training images and your training labels. And you're going to change right here patches to be sample images and images as a parameter. And those are the only changes there. And in the sparse autoencoder, I don't think I changed anything here. So the point of this is that you were supposed to take any sort of loops in the sparse autoencoder cost.m file and use vectorization to optimize this. So I'm not actually using any loops in here. And then another thing you need to do is in your train.m file, you need to change visible size, hidden size, and sparsity parm to these values here. And your lambda also. And I think beta is already set to 3. So what you do is you go to your console and you type in train. And you get an image like this. And what it's going to do is classify or do training on the image using unsupervised learning. And this takes about 15 to 20 minutes to run. So I'm obviously not going to make you guys wait here for 15 to 20 minutes, but I'll just show you what the output is supposed to be. So after that runs, you should get an image that looks like this. So in the tutorial it says after 400 iterations, but when I run it, it takes more iterations than that. So your autoencoder should have learned features that resemble pen strokes. So it's learned to represent handwritten characters in terms of what pen strokes appear in an image. And that's about it. So thank you so much for watching. Happy coding!